Hello students, so this is Dr. Zhong, who is the instructor of CSIT111, Fundamentals of Programming 1 in the summer semester of 2020. So due to this COVID-19 pandemic, our course has been transferred to online totally. So there is going to be a lot of difference between this summer semester compared with the other semesters, but you don't need to worry too much about that because I'm going to make sure that everybody can receive quality education. Okay, so and learn some programming skills from that. So first we're going to use the textbook named Java Software Solution Foundations of Programming Design, the 9th edition. So last week I checked it and I found that on Amazon it's already out of stock. But if you go to some other websites like the Pearson website, you should be able to find it. And the price is around 30 bucks. And and if you take the course CSIT112 also, please note that both these courses are going to use the same textbook. The only difference is that CSIT111 covers the first 7 chapters of the book, and while CSIT112 covers the last 5 or 6 chapters of that book. So if you are going to take CSIT112, it's actually a good investment for you, and it's your money is going to worth it. Okay, so here then let's come to the to our tentative schedule. Let's just go to the evaluation metric over here because I think most of you pay a lot of attention to it. So as I said, in CSIT111 we're going to cover the first 7 chapters of the book. So and each chapter is going to be associated with a different weight in calculating your final grade. Okay, so in since we only have 4 weeks, actually it's not even 4 weeks, it's a little bit it's like, let me say, how long do we have? We have 3 weeks plus 4 days. Okay, so this is what we have. So we're going to in the first week we're going to go over the first 2 chapters, and then in the second week we're going to go over the second 2 chapters, and then in the third week we're going to cover chapter 5 and 6, and in the last week we're going to cover chapter 7. Okay, so this is the tentative schedule, and as you can see over here, from all the 7 chapters, the most important chapters includes chapter 2, 3, and 5. Okay, so pay attention to them. And regarding our teaching style, okay, what I'm going to do is that on every Sunday, say on this Sunday evening, or either on Sunday or on Monday morning, I'm going to upload a video to my YouTube channel. Okay, so this video is not going to be very long. It's like 40 minutes, 1 hour. It's kind of like that, which gives you a highlight about the content that we're going to cover in the next week. And so I'm going to talk about the most important part and the most difficult part. Okay, so it's not going to be very long. And after that, okay, so as you can see that I have already provided you the slides. Okay, and so after that, I suggest you to use the slides plus the textbook to go over the chapters, to learn the content from different chapters. And also if you have already logged into Canvas, you should be able to say in our announcement part, I provide you detailed instructions on how to register an account on a website called My Programming Lab. So My Programming Lab, or in short, MPL. Okay, MPL is basically an online website which provides you interactive programming, say interfaces. So if you say after you type in your program, you should be able to say if your program is correct or not very easily, okay, and instantly. And we are going to use that in both courses to reduce the level of difficulty from you. So um, so average for every chapter you're going to have some assignment on MPL. So the assignment on chapter 1 is going to due on the Thursday of the first week, and then chapter 2, the assignment for chapter 2 on MPL is going to due on the Sunday of the first week. And so for chapter 3, it's going to be due on the Thursday of the second week, and then chapter 3, if the practice on chapter 4 is going to be due on the Sunday of the second week. So basically, for each chapter, it is going to be due on either Thursday or Sunday, depending on if it's an odd number or I forgot how to say that, okay, but you know what I mean. For chapter 1 or 3 or 5 or 7, it's going to be due on Thursday, and for chapter 2, 4, 6, it's going to be due on Sunday, okay. So so your overall grade is going to be totally evaluated by based on your performance on MPL, okay. So pay good attention to that. And also so I'll say after you submit your assignment or practice on Thursday on MPL, on the next day on Friday or on Monday, you will be able to have the access to the correct solutions of the practices. So you can go over that to say if you make a mistake, go over the correct solutions to say, okay, what kind of mistake did you make, and in the future, then pay more attention to that, okay. So in my opinion, okay, this course is going to be kind of like medium level of difficulty, okay. By saying that, okay, what I mean is that every week I expect you to say pay around 1 hour to go through the 1 hour for the YouTube video, and then you should spend for each chapter you should spend around 3 or to 4 hours on the just for to read the textbook and the slides, and this is for each chapter, because and most likely we're going to cover 2 chapters a week, so you can just multiply it by 2, and then so the my programming lab practices for each chapter is going to take you around 1 to 2 hours. So, and again we should multiply it by 2, so in total the total number of hours that this course demands from you is around 12 hours per week. So it's not too bad or it's not too good. So the main reason is because we have a very compact schedule. We only have a little bit, so 3 weeks and 4 days to go through one course. But say if you distribute this 12 hours on, let's say, 4 days, it's like 3 hours a day, and which is not too bad, right? So okay, and also today I have already received an email from students asking me, okay, if we're going to have some synchronized lecture time on Zoom or some other platform. The answer is no. The reason is that, okay, before, let's say, date back to early May or in the end of April, I have already received around 4 emails from this class. The students they have their job as I'm not sure if it's a part-time job or full-time job. They have their job as a healthcare worker, so or at least essential business. Okay, so they told me that nowadays they have longer work hours than usual, so they're not going to be able to make the synchronized online meeting time for this class during the summer. So what I propose to do is that, okay, I want to make this course kind of like flexible for you. The material that I provide are the YouTube and the slides and the Mac programming lab. For this kind of materials, you can do it at your convenience at any time that you want, as long as you submit them on time. And plus, okay, if you have a difficulty, or if you have a very tight schedule at some point when we are having this course, please send me an email so that I can give you an extension on your MPL lab assignment. Okay, so let's make it flexible. And also, so besides that, I'm going to provide my office hours on Zoom. Sorry, office hours on Zoom. So on every Thursday from 10:30 to 11:30 a.m. So to answer any question that you have, I'm going to share the Zoom link to you on Canvas later. So take advantage of that if you have any question. Okay. So and if you want me to have more office hours, please let me know. I can schedule it. So this is pretty much everything that I want to talk about in our syllabi. And next, so I'm going to go over the relatively important content in chapter 1. So chapter 1 is basically an introduction to this course, and the relatively important part are here. So the computer components of a computer, and then so an introduction to Java. Okay, so these are the relatively important parts. So let me go through them first. So here, the first figure that I'm going to talk about is this one. Okay, so if you are familiar with our computer with computer hardware, or if you have, especially for those of you who have any experience with assembling a computer by yourself, you should be able to know that our computer, the relatively important hardware components of our computer includes a CPU, central processing unit, main memory, okay, or we call it a RAM. And then disk, which is, or we can call them hard drive. Okay, so these are the relatively important parts of our computer. And say so for now, if you have a program, say if you use Unix, your executable program is going to be in the format of bin. Bin stands for binary. Okay, if you use Windows, your executable program is going to be in the format of exe. So suppose that initially you have your program stored in your hard drive. Okay, and then for some time, for example, it's a video game. It's a very big video game. Let's say x.exe. And you want to execute it. So like from the name of the hardware, central processing unit, you should be able to tell, okay, this is the place where the execution, or sorry, where the instructions get executed. So if we want to execute a program, the program must go to the CPU to be executed. But unfortunately, the CPU cannot directly retrieve the file or the program from the hard drive. No, this is not possible. And instead, what it does is that, okay, first we load the program into main memory. Suppose in main memory it occupies this portion of the RAM, of the space, and each time when our CPU wants to execute the program, each time it's going to retrieve a small portion of the instructions from the main memory and execute it. Next time it's going to retrieve another small portion of it and execute it. So this is the architecture of our computer hardware. And next, let's go to check what is Java. Okay, so Okay, Java is basically a programming language. So let's use a more intuitive way to explain what is a programming language. So suppose now we have two people, person A and person B. So person A only knows, let's say, only person A speaks both Spanish and English. Okay, so but his main language is just Spanish. His English is relatively okay, but not very good. And person B, main language is French. Who knows a little about English. So in order for these two people to communicate with each other, what they need to do is that they need to have a language in common in order to be able to communicate with each other. So what they do is that person B first thinks about a sentence in French because that is his main language, and from himself he has a sentence in French. So first he has a sentence in French. Let me use SF to denote that. Okay, and then he translated to English, even though the organization of the sentence in English may be relatively poor, and then send this sentence to A. And when A hears this sentence, he tries to recognize the words and then translate it back to Spanish, word by word. So then the person A is able to understand the meaning of the person B, and then in this way they are able to communicate with each other. So this is how two people who understands different language talk with each other. Similar over here. Say we suppose that we have a computer and we have a person or a programmer. So the programmer want our computer to understand us by say we want if we want our computer to do something, we want our computer must understand what do we want to understand our instructions and then execute the commands, correct? So but unfortunately the main language that is spoken by our computer is called binary. So binary means either 0 or 1, so in the binary format. But for us, a programmer, it's not a programmer, it's a programmer. For us, a programmer only knows some language. Let's say, for example, let's go back to the previous slide. Only knows a language called, say, English. Now the problem comes. So the programmer only knows English, but the computer only knows binary instructions. So how could they communicate? How could the computer understands a programmer's intention? So then people design something called programming language. So a programming language is basically a language that both the computer and the programmer understands a little as a second language. Not very good at it, but yes, at least they can do that word by word. So then there are different choices of programming languages. So nowadays we have the mainstream programming languages includes C or C++, and then Java and Python. So at the current time in the industry, Java still is the mainstream one, while even though Python is a rising star. So probably in 10 years we're going to say Python is going to be the number one in industry. So here let's stick to Java. So the programmer just pays a couple of years, say 1 year or 2 years in college, and learn some Java, and our computer also understands Java a little. So in this way, suppose that we want our computer to do something, let's say to read an image and then say to recognize the people from their images. Then we know we know what we want the computer to do, and then we need to translate it to Java, and then so the computer reads our like program written in Java, and it is able to understand it and translate it back to binary format, and then execute it. So here, I hope that this example can let you understand what is a programming language, and basically Java is just a programming language. So one type of programming language. Okay, so here you can say how does our computer recognize Java source code. So suppose that we have a file which is the Java source code, the program written in Java. So in order for the computer to understand it, first it will need to do a translation. So suppose we provide a Java file, a Java source code to our computer. It needs to first do the translation part and translate it to binary format, binary code. Okay, so it is going to use something called a Java compiler to do the translation, which translates the program from Java to binary format, and then so our Java virtual machine is going to be able to execute it. So that's it. That's how we say develop and execute a Java program. Okay. Next, let's go to chapter 2. Okay. So in chapter 2, we are going to cover chapter 2 basically covers the following 6 components, which includes character strings, variables, and assignments, primitive data types, expressions, data conversion, and interactive programs. You can totally skip the last part because it's not important at all. And the relatively more important part includes the variables and assignments and primitive data types. So I'm going to talk a little bit about them in the video, and then leave the other parts for you because they're pretty easy. As long as you read the book and the slides, you should be able to understand it at ease. So first, let's talk about primitive data types. So in Java, there are 8 types of 8 primitive data types. Primitive basically means basic. Okay, so suppose that we have a number which is an integer, let's say 1000. We want to store it in a variable. So then there are 4 different types of variables that can store an integer value. So which are byte, short, int, and long. So the more important parts include int and long. So we rarely use byte or short. Int is the in short for integer. Okay, so this is pretty easy to understand. So an integer type, and long means long. The long type is actually for long integer. So here from the name you can say that okay, in situations where we have a value like this 1000, 1000, 1000, 1000, if we have a very long number, we should store it in long format rather than int, because int has a relatively small capacity, but it only occupies a small memory space, whereas long is longer. Okay, it takes longer space. And then but say now if we have a decimal value, let's say 2.54 something, okay, we want to store it in a variable. So there are 2 types of variables that can be used, either float or double. Okay, again, float is like just to store regular decimal values, while double is to store long decimal values. And so in order for so then the third type is called character. Okay, char is for character. What is a character? Okay, a character is something like A or B or C. It only includes one character, and it has to be surrounded by a quote, a pair of quotes to denote, okay, this type is character. Okay, and the last type is called boolean. This type is relatively more difficult to understand. Okay, let's say so a boolean variable can only have one of the following two values, either true or false. So in situations where we want to make some judgment, for example, if we want to check if a person's age, if we have an age variable, we want to check if the person's age is older than, let's say, 65, then if this value, so this based on the value of age, this statement is going to return either true or false. So if its age is larger than 65, it will return true. Otherwise, it will return false. And next, let's say how are we going to use these variables. So let me say. Okay, so let me go back. Okay, so let's go back to the variable. Okay, yes, variables. So in order for us to create a variable basically stores some value, and the value in it, and the value stored can be changed, can change over time. So this is what we mean by a variable. In order for us to define a variable, we need to have a data type first. We need to say, okay, what type it is, and then what kind of value do we want this variable to store, and then followed by a variable name. So for example, okay, if we want to create a variable that stores integer values, we can do this. Int is the data type, and the variable name is total. Okay, so this is how, and followed by a semicolon. A semicolon is like a line, a return in Java. Okay, it signifies the end of a line. It says, okay, I finished my line, and then we can just so after that we're pretty free to assign values to it. So for example, after we create a value, say total, a variable total, we can assign any value as long as it is integer to it. So let's say we can say it is 50, or over some time we can store a new value, or we can assign a new value to it, let's say 20. Okay, this operator equal means that we are going to assign the value on the right hand side to the variable at the left hand side. So we're going to assign 50 to this variable, or we're going to assign 20 to this variable. Okay, so remember, this equal sign means assignment, value assignment. And the value assignment, so we can do it in a different way. Say we have another integer, say x, and then we have x. So here we can use the variable of total and assign it to x. So we can do it in this way. We have x equal to total. This means that we're going to use the value stored in total and assign it to x. So after that, x is going to have a value. The value of x is going to be 20. Okay. So x is going to have a new value 20. So say next, here some of you may wonder, okay, if the equal sign is for assignment, then how can we compare if two values are the same or not? Okay, so for example, someone wants to say if x equal to total. Okay, so to do that, we need to use double equal. Double equal means which help us does value comparison. Okay, if they have the same value, it will return true. It will return true. Otherwise, it will return false. Okay, so pay attention to that. Okay, the equal sign means assignment. It does not mean that we're going to check the value equality. No, and whereas double equal sign means value comparison. Okay, so this is the only difficult point in the second chapter. So I'm done with that. So if you have any question, you can just feel free to send me an email or talk with me during the office hour. Okay. So have a productive learning process.